Okay, so far we discussed functions and property of functions, right? And I have already shared you a PDF. There are many exercises in that. So you try to solve those exercises. And we'll discuss problem sessions and practicals. I will tell you. And one more thing, on Saturday 12 to 12:25, we'll have a objective test, right? So test 2 will be on Saturday 12 to 12:30 25. So it will be of 10 marks test for 25 minutes, right? And after that at 12:40 we'll discuss solutions, right? Okay, is this clear?
It should be on function. No?
Yes, topic will be functions. As we conducted the first test. Okay, so we discussed many properties of functions and various
So,
functions.
sir,
Yes.
so this will count in the CE2.
Pardon?
This will be our CE2,
Yeah,
the
don't bother
second
about
test.
it. I will conduct 3-4 tests and I will consider maximum of it. So you don't worry about marks and all these things, right? I will give assignments also. Only thing is you have to learn all these things sincerely, right? So I will conduct many tests, and 3 or 4 tests I will consider maximum of it. So there is nothing like C1 and C2. Finally, you will get marks out of 50 for out of 25 for internal, right? Okay, any doubt? So today we'll discuss some algebra of polynomials, right? So polynomials and theory of equations. Basically polynomial equations and how uh, to find roots of some polynomials, and algebraically what are the properties of roots. All these things we'll discuss. We'll mostly discuss up to degree 3, or for some in some cases degree 4, right? So while discussing about relations, what we discussed about integers, and what properties of integers we discussed. So divisibility, so divisibility of integers. So what do you know about integers? So if a and b are integers and b is not equal to a is not equal to 0, then we say that a divides b. B means what? When we say that a divides b, or a is a divisor of b in integers, when we say that a is a divisor of b, 2 divides 6. Why?
When ratio is also integer.
Right, that means if there exists another integer c such that b is equal to c times a, right, that means a is a factor of b, right? So that is a is a factor of b. Right. So otherwise we cannot say a divides b. For example, 2 divides 6. Why? Because 6 is 2 times 3. That means there is another factor c, and the product is 6. Right. So if you look at 2 and 5, 2 does not divide 5. 2 does not divide 5. Is it right? Yeah. Because
Yes.
there is no such c, no integer c such that we can write 5 is 2 times c. This expression is not possible for any integer c. Right. So if a divides b, then we write it as a divides b. This is a vertical line, not a slanting line or not horizontal line. A divides b. Right. What is the meaning of this? A divides b. So therefore a divides b means what? A divides, that means what? A is a factor of b. That means there exists c integer such that b is equal to ac. Right. So for example, can I say that 2 divides 10? Is it true?
Yes, sir.
Right. Or I can say that 3 divides 15. Right. So this is true. Now, can we think about so integers are some special numbers which we already use in day-to-day life, right? And there is a something abstract thing or more general thing like integers, and that is what we call it as polynomials, right? So now what basically polynomials are? So uh, an expression an x raised to n plus an minus 1 x raised to n minus 1 a1x plus a0, where a1 a0 a1 a2 a3 an are real numbers, right, is called as a polynomial over r. Polynomial over r means these constants or coefficients are real numbers, right? So these constants are real numbers, then it is called as a polynomial. So here a0 a1 an are called as coefficients, right? These are called as a coefficients. If coefficients are real numbers, then it is called as a polynomial over r. So and x is called as indeterminate. So what is the meaning of indeterminate? So x do not have any value at all, right? X is just to the power of x and which coefficients. So in polynomial x do not have any value or do not have any special characteristics, right? It is so x to the power 1, x to the power 2, x to the power 3, x to the power n. So these are just the positions in polynomial that corresponds to the which term, which coefficients assigned with which term, right? That is actually it means, right? So that's why it is called as the indeterminate. Indeterminate means x do not have any value as such. When we evaluate polynomial at some point, then that is a different story. But as far as only polynomial is concerned, x is just indeterminate. Right. So for example, so if I consider fx is equal to polynomial 3x square plus 5x plus 6, is it polynomial in R over R?
Yes.
Polynomial over R, right? Because coefficients are real numbers. Now I can identify this polynomial 3x square plus 5x plus 6. So in polynomial, what is 3 is a coefficient of x square, right? What is 5 coefficients of x, x to the power 1, right? And what is 6 coefficient of x to the power 0, right? Therefore I can write, so we can write this polynomial 3x square plus 5x plus 6 as 3, 5, 6, right? What does it mean? If I am understanding that, if I know rule that this is a coefficient of constant term or x to the power 0, if I know that this is a coefficient of x to the power 1 and this is a coefficient of x to the power 2, then I can understand that this is a polynomial what 3x square plus 5x plus 6, that I can understand, right? So therefore with this understanding, if I write something like this 1, 5, 6, 7, can you tell me what is a corresponding polynomial?
X raised to 4,
X cube,
cube,
5x square plus 6x
and
plus
7.
7.
So 1 into x raised to something plus 5 into x raised to something plus 6 into x raised to something, right? Plus 7 into x raised to something. So here I will start with x raised to 0, x raised to 1, x raised to 2, x raised to 3, right? And therefore actually this is a polynomial x cube plus 5x square plus 6x plus 7, right? And therefore what is the role of powers of x in this polynomial? You understand what is the role of powers of x in this polynomial? Only the place where that particular coefficient is, nothing else. That's why it is called as indeterminate, correct? And most of the times if you apply all these ideas in more abstract manner, then you can identify these polynomials by this like vectors. You can identify these polynomials by vectors. If your understanding is that first one is a coefficient of x raised to 0, second one is a coefficient of x to the power 1, and so on. With this understanding, uh, you can identify polynomials by vectors, right? So if f of x is equal to an x to the power n, an minus 1 x to the power n minus 1, and so on, a1x plus a0, then I can identify this with what? an minus 1, an minus 2, and so on, right? A0. So I can identify this. And how many components do this vector have?
n plus 1.
N
plus n plus
n plus 1 components. Very good. So, and why I'm telling this, because this will help us how to add two polynomials and how to multiply, how to subtract, how to multiply by constants. So in that case, because you have already uh, know that if you have two vectors 1, 2, 3 and 5, 6, 7, how do you add two vectors? These two vectors, you know how to add two vectors?
Add their components.
Yes, component wise. Exactly in same manner we are going to add the polynomials, right? And therefore there is no role of x as such. It is just for the position, right? So therefore if you add polynomials, so second definition, an expression an x raised to n plus an minus 1 x raised to n minus 1 a1x plus a0, where a0, a1, an are suppose rational numbers, then fx is a polynomial over q, because coefficients are rational numbers, right? Not irrational numbers. If a0, a1, a2, an are integers, then we say that, right, if coefficients are integers, then we say that fx is a polynomial
oriented.
over integers, because coefficients are integers. Sometimes coefficients are not integers, but and in each case polynomials have some special properties. If polynomials is over integers or over rational numbers, then property changes, and that we'll discuss what property changes, right? The set of all polynomials with real coefficients is denoted by Rx, right? So what is the set of all possible polynomials? Therefore, what is Rx? Set of all polynomials with real coefficients, right? All polynomials. So for example, if you write fx is equal to x square plus root 2x plus 5 by 6, is it in Rx? Is it in Rx? Yes.
Yes.
No, sir.
No, sir.
When this, why not? What are the coefficients? What are coefficients?
1 root 2 and
5 by 6, right? So aren't these number real numbers? Are these numbers real numbers or not?
Yes, real number.
All
Yes,
these
sir,
are
they
real
are.
numbers. So coefficients are real
Yes, sir.
numbers. So polynomial is in Rx, correct? Right? So it is over R. Now is fx belongs to qx? Is in
No, sir.
qx? No, because
No, sir.
coefficients are not rationals. Is fx in zx? Is
No.
it in? No, because coefficients are not integers. Okay, if I consider another polynomial gx, so x raised to 5 plus 2 plus 3i x plus 7, right? Is it in Rx? What is
No.
I? I is
No.
I. No, right? Because coefficients are not real. Coefficients are complex numbers. So it is not in Rx, but is it in Cx? That means are coefficients complex?
Yes.
Yes,
Yes.
right. So, so, so please keep your mic, mute yourself. So let fx is equal to an x raised to n plus a1x plus a0. Then what is degree of polynomial? Degree of fx is the largest
N.
of k such that ak is not equal to 0, right? So degree of fx is the largest value of k such that ak is not equal to 0. So for example, if I write f of x is equal to 0 times x raised to 5 plus 0 times x raised to 4 plus 3 x raised to 3 plus 7 x raised to 2 plus 1. So what is the degree of this polynomial?
3.
3.
3.
Because
3.
first two term doesn't make sense because their coefficients are 0. What is the largest coefficient? A3,
3.
A2. What is A1? A1 is 0 times x plus 1, right? So A1 and A0. So largest k, so that ak is non-zero, is 3. This is A4, A5. So A5 is 0, but largest non-zero is A3, and therefore degree is 3. So degree of largest value of k is that ak is non-zero is the degree. So degree of fx in this case is 3, not 4 or 5, right? So if fx is equal to x raised to 7 plus x raised to 3 plus 5x square plus 9x plus 10. So degree is, what is degree?
7.
Right, because
Seven.
I can also write this polynomial as x raised to 7 plus 0 times x raised to 6 plus 0 times x raised to 5 plus 0 times x raised to 4 plus x raised to 3. This is 1, coefficient 1 here. So 5 times x raised to 2 plus 9 times x plus 10. So some coefficients are in between 0, right? For example, if you look at A7, A6, A5, A4, A3, A2, A1, A0. So A6 is 0, is 0, A4 is 0. But A7 is non-zero. What is the largest k so that ak is non-zero?
7.
Right. So A7 is non-zero and k is equal to 7 is the largest. A6 is also 0. K is equal to 6, then A6 is 0. Right, so largest value of k is 7. So degree of this polynomial is 7. Right. Okay, now so let fx is equal to an x raised to n plus an minus 1 x raised to n minus 1 is 0 and gx is equal to am x raised to m plus a minus 1 x raised to m minus 1. Okay, I should make some different notations here because polynomial is different, so coefficients are also different from the previous polynomial. So bm x raised to m plus bm minus 1 x raised to m minus 1 plus b1 x plus b0. Now what is the degree of this f? What is the degree of f? Unless
N.
unless I mention that an is non-zero, so an is non-zero and bm is non-zero. That means certainly these coefficients are non-zero, right? Therefore, degree of f is n. Now I can definitely say that degree is n. Degree of g is m because the coefficients are non-zero. Highest degree term coefficients are non-zero, so degree is n. Then addition of f and g is fx plus gx. Now I want to add these two polynomials. So how do I am going to add? How am I going to add these polynomials? Right?
The same degree polynomials coefficient
So we'll add
can be
coefficient of
added.
same degree, right? That means uh, if you look at fx is equal to x square plus 5x plus 6 and gx is equal to x cube plus 3x square plus 7x plus 1. So constant term with constant term, degree 1 term with degree 1, right? Degree 2 term with degree 2, and what is a degree 3 term in first polynomial? 0x cube, right? Therefore we'll add 1 plus 0 as it is. That is a way to add two polynomials. So but it depends on which is larger and which is smaller, correct? So add, so if I want to define addition, I should define it properly. Key, suppose degrees are same. So what I should say here, if and suppose n is greater equal m, they are equal or greater. If not equal, one of them is bigger, another is smaller, right? M is greater than 1 or n is greater than m. But in any case, we can define addition. So suppose n is greater equal m, then fx plus gx, right? So suppose n is greater equal m, then how will you add a naught plus b naught? Constant with added with constants are added with constant of another, a1 plus b1 into x and so on. So when I say n is greater equal m, that means suppose m is equal to 10 and n is equal to 12, right? Then which will come first? Am will come first. So am plus bm x raised to m. After happen, after that what will happen? How do I define?
It will be just the
Only the 8.
remaining terms of f polynomial.
So that means B11 is 0, B12 is 0, correct? A11 may not be 0 and A12 is not 0. Right, and therefore after that, after m, what will happen? Which coefficient will be only considered?
AM.
A m plus 1 x raised to m plus 1, because next a m plus 2 x raised to m plus 2 and up to a n x raised to n, because we are assuming n is greater. If m is greater than n, then other way, right? You can understand how do we are. So how we are adding these two polynomials in this particular example? What is fx plus gx? How do we add these two polynomials? First we add constant 1 plus 6, then we add coefficient of degree 1 term, so 5 plus 7x, then what we add? Degree 2 terms, 3 plus 1 x square. But for after next, which coefficient will consider? Only 1 plus 0 x cube, that means only a3 or coefficient of g, x cube in g. So as it is, so in this way we add two polynomials coefficient wise. And if you remember, if you look at these two polynomials as a vectors, right, 0 1 5 6, and second polynomial as a vector, so 1 3 7 1. How do we add two vectors? Right, 1 4 12 7. And what is a corresponding polynomial? This is a corresponding polynomial, right? Is this clear what I said? And gx is equal to x raised to 10 plus 8x raised to 9 plus 10x cube plus 20x plus 100. So find fx plus gx, right? So you can easily find this, correct? So let fx is equal to x raised to m, an minus 1 x raised to n minus 1 plus a1x plus a0, and gx is equal to bm x raised to m plus bm minus 1 x raised to m minus 1 plus b1x plus b0, right? So these coefficients are distinct, that means these two are different polynomials. Then fx and gx are equal two polynomials are equal if, when we say that two polynomials are equal, yes, we understand
If
when
degrees and coefficients are equal.
right, if m is equal to n and ai is equal to bi for all I is equal to 0 to n or m, whatever is. All coefficients are equal and degree is also equal, then we say that polynomial are equal. Only degree equal is not sufficient. Their coefficient should be same. Right? For example, if f of x is equal to uh, ax square plus bx plus c and gx is equal to 2x square plus 5x plus 9, then f of x is equal to gx means what? So fx is equal to gx means what?
A equals to 2,
A
B
equal
equals
to
to
2,
7,
B
C is
equal
to
to 5.
A is
5.
equal to 2, B is equal to 5, and C is equal to 9. Then only we say that these two polynomials are equal. Right? So, zero polynomial. A polynomial fx is said to be a zero polynomial if, when we say that a1 a0 is equal to 0, a1 is equal to 0, a2 is equal to 0 if all coefficients are 0, right? If all its coefficients are 0. So zero polynomial is denoted by 0, right? Zero polynomial is also denoted by 0, but it is a polynomial because the 0 as a real number 0 and polynomial as a real number 0, there is a difference. That is, what is a zero polynomial? 0 times x raised to n plus 0 times x raised to n minus 1, right? 0 times x plus 0 as a polynomial, and if you identify this as a vector, it is just 0 0 0 vector, right? And because 0 in R2 and 0 in R, is there any difference? Is there any difference in 0 in R2 and 0 in R?
In R2 it will be 0 comma 0, in R it's just
Right.
0.
It is just simple real number 0. And therefore, when I say zero polynomial means that is, it is actually a such kind of thing which has many components. Right. So is it clear?
Yes.
Okay. So let fx is equal to ax square plus bx plus c, and gx is equal to 3x cube plus 5x square plus 7x plus 9 if fx minus gx is zero polynomial. Then what are the values of a, b, c? Suppose it is given that the difference of polynomials is 0 as a zero polynomial. Then what are the values of a, b, c?
A is equals to 5, B is equals to 7, and C is equals to 9.
Okay, I have to make some change here, otherwise there is a problem. D. Find values of a, b, c, d.
B equals to 0, A equals to
Yeah.
5, B equals to 7, C is equal to 9.
That means first of all we should write what is fx minus gx. So what is fx minus gx? D minus 0 x cube, right? 5 minus a x square plus 7 minus b x plus 9 minus c. This is my polynomial f minus g, and it is 0. Therefore all coefficients are 0. So d minus 0 is 0. So d is equal to 0. A is equal to 5. Right. B is equal to 7 and C is equal to 9. So these are the values. Right. So similarly, so addition and subtraction both are similar things. So how to subtract two polynomials and how to add
So,
two? Yes.
so it will be 0 minus d na for f of x and a minus 5.
Oh, right. 0 minus t. 0 minus t. Correct. And therefore d is equal to 0 in any case. Correct. Fine.
Answer for others values also a minus 5 and b minus 7.
A minus O. A minus 5 Any. Now you can understand the subtraction. So let fx is equal to an x raised to n plus an minus 1 x raised to n minus 1 a1x plus a0. If an is non-zero, then degree of f is n, right? N is non-zero, therefore degree of f is the quotient n is called as the leading coefficient of f. Leading coefficient. So leading means the coefficient of highest degree term. Coefficient of highest degree term. So that means coefficient of leading term is called as leading coefficient, right? Because highest degree non-zero is x raised to the power n, and its coefficient is a leading coefficient. So if leading coefficient is 1, then polynomial is called as monic polynomial. Right. If leading coefficient is 1, then polynomial is called as monic polynomial. Right? Yes.
Yes, sir.
So if f of x is equal to constant, right? F of x is equal to constant. Constant means what? For example, if I have f of x is equal to 5, is it a polynomial?
Yes.
Yes. So polynomial of degree 0.
5x0.
Right, it is a polynomial of degree 0 because x to the power 0 and x to the power 1 or all higher power degree terms are 0. So is called as a constant polynomial. Right, or polynomial of degree 0 is called as a constant polynomial. In other words, right, that is a polynomial of degree 0 is called as constant polynomial. Right, so therefore every real number is a polynomial, every integer is also polynomial. Right, is this clear?
Sir, I have a question.
Yes.
So if we have a polynomial that is not monic, uh, we can divide the whole polynomial by the leading coefficient and make it a monic polynomial, right?
Yes, exactly.
So if any number satisfies a normal polynomial, we can also say that it will satisfy a monic polynomial, right?
Actually not. If you are in rational, then it is okay. But if you are in integers, then that is different thing, right? For
Nah, a
example,
monic polynomial with rational coefficients.
then it is fine, no problem. That we'll discuss later on.
Okay, sir.
We'll discuss all. This is polynomial with, you can say, integer coefficients, right? This is polynomial in QX, or you can say also it is polynomial in ZX because quotient. But if you divide by leading coefficient, right, f of x by 3, what it would be? X square plus 5 by 3x plus 7 by 3. Basically, this polynomial is in ZX also because coefficients are integers. But if you divide by 3, it is not remains inside ZX. Right? But it still remains inside QX. It still remains inside QX, but not remains inside ZX. So we'll address all these issues later on. How to do this rational coefficients and integer coefficient polynomial behaves and how they are interrelated. Right. So f of x is equal to ax plus b. So a and b are real numbers. Right. So what is the speciality of this polynomial? So if you look at f of x plus y is a times x plus y plus b, ax plus ay plus b. Right. So this constant, if you neglect the constant term, all other terms you can distribute, coefficients can be distributed. So if you look at this polynomial ax, gx is equal to x. Is it a polynomial? Is it a polynomial?
Yes, sir.
Yes. A times x plus y. If I apply this polynomial on two numbers, sum of two numbers, is it ax plus ay, and therefore it is gx plus gy. It is gx plus gy. Therefore, if you apply this polynomial on sum of two elements x and y, then it is sum of their action on each element. Right. So this property is called as linearity. Right. And if I have a polynomial like hx is equal to x square, will this polynomial satisfy same property? Will it satisfy same property like g?
No.
No, sir.
No, it is not same as hx plus hy. That means it is not same as x square plus y square. So linearity fails, and therefore from this, when linearity is preserved, do you understand from these two examples when linearity is preserved?
In degree of the polynomial is 1.
Right. If degree of polynomial is 1, then only linearity is preserved, and therefore degree greater than 1 is, in that case, linearity is not preserved. So f of x is equal to ax plus b is called as linear polynomial. Constant doesn't matter actually in this case, but degree 1 polynomial, right? Degree 1 polynomial is called as, that is degree 1, not less than 1. Degree should be 1. You may have non-zero constant term or zero constant term. Is called as linear polynomial. Right? Okay, so next time we'll explore many properties of polynomials, and interesting properties, how to multiply two polynomials and how to divide polynomial by polynomial. And then we'll think about GCD of two polynomials like integers, right? And after that we'll discuss the roots and properties of roots of polynomial, how to solve polynomials. All these things we'll discuss. So basic thing is you need to understand what is the meaning of polynomial and how to understand or how to relate polynomials with vectors, right? In some sense polynomial behaves like vectors because when we add there is something like addition of two vectors, right? So okay, we should stop here, right? So if you have any doubts,